back to track two. So we have Mr. Srinivas Padhy and Rajat Sen who are going to present their papers to you on AI assisted flaky test indicator. So over to you now.
Thank you, Gaurika, and hope my screen is visible to all. Can someone confirm?
Yes, it's visible.
Yes, yes,
Yep.
Srinivas.
Thank you, Gaurika. So, good afternoon, all. We are going to present about AI-assisted flaky test indicator. I am Srinivas Padhy, test manager working with Ericsson.
I am Rajat Sen, Senior Test Engineer working with Ericsson.
Okay, so let us just understand, and maybe all of you would have seen a test automation report like this, that we ran 235 test cases. Out of those 235 test cases, 81 failed. And because of this, if you see just below that, let me take a pointer. Because of this 34% test failed, our build also got failed. Now, the responsibility of the test automation engineer is to find out the causes of the failures. Now, he finds out that 60 test cases failed due to intermittent issues. And when he executed manually in isolation, they all worked fine. So, is it right to fail the build when you have 60 test cases are failed due to intermittent issues and they are not application failures? The answer is no. We should not be failing the build. Not only that, it for debugging also, these 60 test cases, the automation tester spend a lot of time to come up with this analysis. It's a very time consuming effort. So what are these 60 intermittent issues? So if you look at the right side of it, these 60 test cases actually across various runs perform like this. Sometimes passes, sometimes fails, sometimes passes, sometimes fails. If you see the second test case, same story. Passes, but sometimes fails. And this one is even bad. It fails, sometimes passes, and most of the times it fails. But every time we are not able to figure this out that whether this is an application issue or it's an intermittent issue, what is the cause, why this test case is passing and failing. So the test automation engineer who is always looking into the analysis is always doubtful what happened to this test. When I run it in isolation, it works. So as per a recent survey, it has been found that 20% of tests and continual rate of about 2% of all test runs report a indeterministic result. Now, this is what flaky tests are. Tests that could fail or pass non-deterministically despite no changes to the code or the test itself. I did not make any changes to the test. I did not make any changes to the code. Still, the test cases sometimes fails, sometimes passes. This is what flaky tests are. Now, we had this problem statement before us, and in this continuous software development environment, uh, there are three stages. One is test scripting, then test execution, and the third one is test analysis. We are given time for both the first two parts, the test scripting and test execution. Nobody gives time for test execution analysis. And as an automation engineer, we all know that this is the most time consuming part. And if we find out that these all cases are flaky in nature, that means non deterministic in nature, it reduces the confidence on the test automation as well. Because if you saw that, if 60 test cases come out to be intermittent in nature, next time the developer would say that rerun your test and check because your test cases are always flaky. So we have to be finding out an intelligent way of flaky test detection. This is what we have tried to achieve. Now, most of the times, as I indicated, you have to rerun those tests as a common mitigation strategy uh, to identify whether this test case is passing or failing in actual. We can do that. Most of the people in general does that. Just rerun those tests and find out whether it is passing or not. But what would happen? It would result in delay. But at the same time, when you run it next time, the ambiguity still remains. You still not confirm why it passed and why it failed. So we need a modernized way of test analysis. Now, if you see that these test cases overall slowed down my progress, it cannot be trusted, it may hide my real bugs, and as we understand, it's never going to be cost effective. So we have to find out a way to proactively monitor these flaky tests. So we have come up with a solution uh, which can help in identifying the flaky test. The question before us was that whether these kind of solutions are already present in the market. The answer is yes. Many organizations have developed flaky test management tools, but they are either internal to their organizations or applicable to specific test frameworks. No open source solutions were there. Otherwise, we would have used it. So what we did is we tried to apply machine learning using open source tools technologies on test results, agnostic of test automation frameworks to identify flakes. And the previous problem was that you have to rerun that test to identify the flakiness. In our case, you do not have to rerun that test. This tool is going to identify the correlations with the features that will enable to identify flaky result accurately without rerunning the test, thereby reducing our technical debt. Because of all this, since we are proactively monitoring the flaky tests, we have got an intelligent flaky test detection mechanism. Definitely the confidence on test automation will improve and your technical debt has to be resolved. So we talked about why we came across this problem and what could be the solution. Let us understand the technical details about it. What would be my functional flow? So basically, I would run my test cases across various runs. These execution results, I'll pass it to a machine learning algorithm, and this algorithm will be presenting me the test cases and an overall dashboard. And the data flow looks like this. What we need test execution logs of any test automation framework, and the output we would get is flaky test cases out of all the test cases that you provide along with a flakiness score. I'll come back to flakiness score when we see the demo. So let's quickly go to the demo and see how it looks like. First of all, let me show you the output XML files. These are the logs that are uh, provided as an input that I was talking about, test execution logs. Now, I ran this app, and if I go here, I'll just provide the path of this input, and it is going to give me the flaky test overall along with a flaky score. Now, this flaky score is calculated and tells me the likelihood of the flakiness, meaning higher the flaky score, more is the flakiness. That means this particular test, which is 89% flaky, this tool tells, that means this is the most urgent test that you have to fix it so that it doesn't block anything and becomes non-flaky. So these it just happens in few minutes. Otherwise, you would have spent around hours to identify why this test is failing or passing across various runs. And as I told you, do not have to rerun across various runs. It is going to tell you that this is your flaky test or a probable flaky test with a flaky score. And Overall, I ran here around 500 test cases, which tells me that 91% test cases are not flaky. But yes, in this particular input file, I found that 9% of test cases are flaky. So this is how it looks like. Now I'll quickly go here, and I am going to explain the solution architecture as well in a while, but just be with me to understand few lines of these things. One is the app.py, data clean.py, find your flakes, robot results.py. So basically we are here converting the robot framework execution logs, and here we will be training a model, and then we will get a train data. I'll show a solution architecture about it also, but just uh, be with me to understand these steps. Let me go to the solution architecture quickly. Now, this will help you to explain how it is being done. So, any test automation framework, be it XML, logs, or any format, this has to be passed to this particular data parsing, and here the data clean.py will come into picture. At the same time, since this test execution logs are basically English, plain English language, right? So we have to apply NLP and try to find out the relevant information, whether the errors were same or different, or what could be the various causes. This all will be done through data clean.py. After that, we have to explore that data to find out various statistics around it, that what are the number of transitions, then what is the average pass time, fail time, and many other things. All those statistics will be derived through both of this, and after that we will provide it to a train data. This was my input data that I was showing before. Post that, if you run any input, if you provide any output logs, this particular piece of Python code will be running, and it will present to your dashboard that I shown. This is how the solution architecture looks like. We have used Python as a language, and major libraries that we have used are Pandas, Scikit, NumPy, Dash, and Plotly. Dash and Plotly is nothing but the UI thing that I shown just a while ago. Now, we have developed this tool, but we still know that there could be many other enhancements around it. And we would be working on this. Now, what are those? One is we have to improve our dashboard enhancements and analytics part. We have to bring in the flaky rate. We have to show the most common errors across the runs of the test case. Now, test results parsing, only the path that I shown robot results.py, we have to build it for other test automation frameworks also, uh, which is pretty easy, that we are already seen that. And the third one is we have to integrate it with test management tools like Jira in version 1, so that a defect can be raised right over there, and somebody from the automation team works on that particular flaky test and resolve the problem before it blocks the DevOps pipeline as such. So as part of conclusion, I can say that don't ignore the flaky test. Many a times as test automation engineers, we tend to leave this test as is, because when I run it in isolation, it passes. There could be many other causes, and you may find that you are missing out uh, a real bug. It waste your time also. So don't ignore it, don't underestimate it. Flaky test is a real problem. We have to solve it as early as possible to ensure that in this digital transformation age, where the test automation plays a very crucial role, we are not blocking any product just because of a bottleneck of testing, of flaky test. Rather, the test, we have to make the test automation as an enabler for digital transformation age. Thank you so much. We are open for any questions now. If we don't have any questions, I guess I have something for you all. Let us go there. I would request the audiences to go to menti.com and use this code and tell me that have you experienced flaky test in your test automation suits? Let's wait. Audiences, can you please try once? It should reflect here if you are trying. Maybe some problem from my side. Rajat, can you try please?
Right, Srini.
Okay, so it's working. Very good. So looks like it is a problem overall. I got two people polling about it. Now three. So it is a problem if we go by this. Four. Everybody is saying okay. So 17% says that never paid attention to flakes. So uh, friends, it's just the right time to pay attention to flakes. But 86% says that it's a problem. So we are on the right path. Very good. Okay, next question. So overall, it looks like 89% it's a problem, 11% never paid attention to flakes, which is very general. So we have to pay attention now and resolve this problem. Let's go to the next question. What could be the causes of test flakiness? Think. There could be many causes like infrastructure problem, network issues, DOM related issues. UI cases are very brittle. So there could be synchronization problems. Yes, environment. Code, yes, test code could also be a problem.
Srinivas, I think we have a question in the comments.
Okay, can you speak about that question?
Right. So, participant is asking, so does this tool provide any support for fixing flaky test too or not?
As on today, the answer is no. It is only able to detect the flakiness because the first problem was to identify the flakiness itself. But yes, the next step would be to fixing those flakiness as well. But currently, it is not doing it. It is only able to identify the flakiness without rerunning the test. So you do not have to rerun your test to identify the flakiness. It is going to predict and tell you that this test case is flaky. It's a technical debt that you are running with. Please find out the issue and fix it. I hope that answered.
And by looking at the Mentimeter results, Srinivas, I think the participants are on the correct track. All the I mean, the answers that we are getting is correctly pointing out the causes of the flakiness that people encounter in the
Absolutely,
projects.
absolutely. These were the cases which causes the flakiness. Environment issues, locators, flawed locator strategy, dynamic application, Ajax JS calls, very right. Synchronization issues, DOM changes, code, environment, SPA, single page applications have their own problems, network latency, system performance. Great. So the data is coming out pretty well now, and I guess we understand this problem, and we have to ensure that as test engineers of digital transformation age, we must ensure that flakiness should not be a blocker for any DevOps pipeline, but make test automation as an enabler towards the DevOps pipeline. Thank you so much, all. Over to you, Gaurika, unless we have any other questions.
Okay, thank you so much. That was very, very nice and very insightful. Do we have? Okay, I think we do have a question. So if you could, so the solution helps to point out to specific part of the test case uh, causing flaskiness. Sorry, can you see the question? It says the solution helps to point out to a specific part of the test
Yes,
case causing flaskiness. Yeah, yeah.
yes, yes, yes,
Flakiness.
yes. It
Okay.
actually correlates various features of a particular test and tells you that this is flakiness. I mean, this particular test is flaky.
Hmm.